Thank you for watching this project help video for lesson 23. I will help you answer each question in the project by providing step-by-step instructions using example problems. A good strategy might be to pause the video after each example and then work the corresponding problem in the project. Let's get started. Problem background. The strength of a Kamehameha for Goku can be modeled by the function g of x equals 10x plus 30, and a Kamehameha for Vegeta can be modeled by the function v of x equals 8x plus 60. Here, x represents the time they charge their Kamehamehas in seconds. Right, so they tell us that the situation can be represented by y is equal to g of x. So remember, g of x is just a way of naming this function, so we could replace it with y. And the same thing with v of x here. It is representing the output variable, or in this case, y. Just for a little bit of extra historical perspective, Kamehameha didn't originally come from Dragon Ball Z, right? It's actually the name of the first Hawaiian king. All right, so question one simply asks, since the y is isolated in both equations of the system, right, you can substitute to get which equation? So kind of a silly question here. We can just replace y is v of x and y is g of x. So you can go and replace one of the y's with one of the functions. And so what I want you to get out of here is that I can just set the two functions equal to each other. Right? And the whole reason we're doing this is that so we can solve this system using a method called substitution. Notice that in this case, I replaced the y right here with g of x. I just replaced it, I substituted it. So continuing on with that theme, it says based on the previous problem, write an equation that can be used to find the value of x. All right, so all I'm going to do then is replace one of the y's, right, with what it is. In this case, set the two functions equal to each other. Remember, was y. This is why they went through that process, and this was y. And if y is really equal to 8x plus 60, then where I have a y in the other function, I can replace it with 8x plus 60. I could also think about it the other way, right? And replace the y down here with 10x plus 30. Either way, we get the exact same equation. In this case, I'm going to write that 8x plus 60 is equal to 10x plus 30. In short, once we get one of the variables by itself, in this case, they were both by themselves, the y was by themselves in both equations, we can just set the equations equal to each other. So in your problem, set the equations equal to each other. Notice now that once we have the equation set equal to each other, we only have one variable left. Remember, when we have an equation with just one variable, we can solve for it. So question 3 is going to state that given that the power level of both Goku and Vegeta's Kamehamehas were the same, how many seconds did they each charge for? Okay, so they had to set the equations equal to each other in question 2 for the purposes of solving for x. And once we solve for x, we will have the answer to question 3 because they want to know how many seconds did they charge for, and that is represented by our x variable in the problem scenario. All right, so I'm going to go ahead and I'm going to solve for x. So I'm going to get all my x terms to one side. It doesn't matter if you get them to the left or to the right as long as they're together on one side. I'm just going to go ahead and subtract this term, 10x, from both sides. And I want them to be together on one side of the equation. So in this case, the x is canceled. We get that negative 2x plus 60 is equal to 30. All right, so I gathered my x's on the left side of this equation. Now I need to push all my constants or numbers to the right-hand side of the equation. So I'm going to subtract 60 from both sides. I'm going to get the equation that negative 2x is equal to negative 30. So we've solved these type of equations before, right, in Unit 1. This is just called a linear equation in one variable. So I'm going to go ahead and divide both sides by negative 2. To isolate the x, remember this means multiply. And so the opposite is division. And a negative divided by a negative is a positive, so we get that x is 15. So in this case, they were charging their Kamehamehas for 15 seconds. Okay, so let's remind ourselves of our answer from question 3, since question 4 depends on it. X is 15, so I'm going to write that up here. Based on your answer to the previous question, what is the power of both of their Kamehamehas? All right, so that means I'm going to go ahead and I'm going to plug in 15 for X. So the way that we solve using substitution is, remember, we get a variable by itself and substitute that into the other equation, solve for that variable. And then the last step is here. Once we have the answer for one of our variables, we just back substitute it back into either one of the original equations, whichever one looks easier. They both look the same. I'm just going to go ahead and plug it into the top equation. It doesn't matter though which one you plug it into, because you'll get the same answer for y. All right, or for the, in this case, the power, which is represented by the output, these functions here. Remember, you could replace these with y. So if I did that, I would have that y is equal to 10 times 15. And I substituted in 15 for the x, because x is 15. We know that now. Plus 30. And I continue solving for y. So I get that 10 times 15 is 150 plus 30. And we get the answer that y is equal to 180. And if we plug that same 15 into the bottom equation, we would have got the exact same answer. We would have got 180. Because remember what these are again. These are lines. And I'm basically looking for where they cross. That's what we're always looking for when we're solving these systems. Question 5 says, explain the steps that you took to find the values of x and y. How do you know you're right? Is there another way to solve and get the same answer? So explaining the steps is just to go back to the slides we talked about and just talk about how I went through and used substitution to first solve this equation for x, and then it's back substituted to get to y, explain the steps. And then how do I know that I'm right? Well, you could check that, right, by plugging in our answer of x is 15 and y is 180 back into each of our original equations and make sure that we get a true statement. All right, so if I did that for the top equation, remember they have to work in both, I'd be saying, is 180 really equal to 10 times 15 plus 30? And we can see that it is. And then it has to work in the second equation too. So I could say, is 180, if I'm using v of x now for Vegeta, is equal to 8 times 15 plus 60. All right, so you could do a little work on your computer. You would get that 8 times 15 is 120. And then is 180 really equal to 120 plus 60? Yes, it is. All right, so it worked out. It checked in both. And for any of these type of problems, you can always check that way. All right, so that'd be one way that I would know that I was right. It's not the only way. It says, is there another way to solve? Yeah, there are. We've learned 2 other methods, right? I could have solved this if I wanted by using graphing. I could have gone to Desmos.com and put in both of those. I would have graphed it and I would have seen where the lines crossed. And the last lesson, we learned how to solve these by using elimination. So there's another way that you could have done it. And in fact, there are even a couple more methods that you won't learn in this class, but there are several ways.